Hello there. Here are some important notes on the nomenclature of chemical compounds. It is my goal to make chemical naming and formula writing easy for you to understand and remember. So, here we go. For inorganic compounds, it is important to know what kind of elements are involved by familiarizing their position in the periodic table. The blue ones on the left and much of those in the middle portion are metals. The brown ones on the right are nonmetals, and a few green ones are metalloids. By the way, the elements are arranged by group or column, and these groups are numbered 1 through 18 from left to right. For ionic compounds, it is also important to know what charges the elements are capable of forming when they gain or lose electrons upon chemical bonding. For your convenience, the charges are labeled at the top. For example, all alkali metals belonging to group 1 would have a charge of positive 1. This includes hydrogen, lithium, sodium, potassium, etc. Group 2 elements known as alkaline earth metals have a positive 2 charge. Some examples are beryllium, magnesium, and calcium. Those belonging to group 13, such as boron and aluminum, have a charge of positive 3. Elements in group 17 are known as halogens, and they have a negative 1 charge. That includes fluorine, chlorine, bromine, and so on. Group 16 elements such as oxygen, sulfur, and selenium have a negative 2 charge, and those belonging to group 15 have a negative 3 charge. Some examples are nitrogen and phosphorus. Now that you are familiar with the type of element and the charges they form, let us begin. For a binary ionic compound, the first element listed is a metal followed by a nonmetal ending in IDE. For example, sodium chloride. In the periodic table, sodium belongs to group 1 and it has a charge of positive 1. Chlorine belongs to group 17 having a charge of negative 1. So we write Na+ for sodium and Cl- for chlorine. Remember that the overall charge of the compound must be 0. For this case, positive 1 plus negative 1 is actually equal to 0. So the correct chemical formula is just NaCl. Next, we have aluminum oxide. Aluminum belongs to group 13 with a positive 3 charge. Oxygen belongs to group 16 having a negative 2 charge. So we write Al3+ and O2-. Remember that we have to balance these two charges. So we should have 2 atoms of aluminum times positive 3 to give us positive 6. Similarly, we should have 3 atoms of oxygen times negative 2 to give us negative 6. A simpler way of doing that is to take the charge of aluminum positive 3 and make it the subscript of oxygen, and take the charge of oxygen negative 2 and make it the subscript of aluminum. And that is how we got the formula Al2O3. What if the ionic compound involves a transition metal which has more than 1 charge? The name of the transition metal should come first, followed by its charge, represented by a Roman numeral enclosed in a parenthesis, and then the nonmetal ending in IDE. For example, we have lead-2 sulfide. The Roman numeral 2 here represents the charge of lead. In the periodic table, lead is found here. It is already indicated that the charge is positive 2. Oxygen belongs to group 16 and of course has a negative 2 charge. So we write Pb2+ and S2-. The charges positive 2 and negative 2 are equal to 0. So the chemical formula is just PbS. Next, we have iron 3 oxide. Iron is a transition metal with a positive 3 charge, and oxygen belongs to group 16 with a negative 2 charge. So we write Fe3+ and O2-. To balance the charges, just do the crisscross method. Positive 3 becomes the subscript of oxygen, and negative 2 becomes the subscript of iron. So we now have Fe2O3. Positive 3 times 2 gives us positive 6, and negative 2 times 3 gives us negative 6. The chemical formula is Fe2O3. This time, let us take a look at ionic compounds with polyatomic ions. The name of the metal is still listed first, followed by the name of the polyatomic ion. As an example, we have calcium phosphate. Calcium belongs to group 2 with a charge of positive 2, and phosphate has a predetermined charge of negative 3, so we write Ca2 plus and PO4 3 minus. Using the crisscross method, 2 becomes the subscript of phosphate and 3 becomes the subscript of calcium. So we now write Ca3 PO4 inside a parenthesis with a subscript of 2. The overall charge of calcium is now positive 6 and the overall charge of phosphate is now negative 6. Therefore, the charges are balanced. And so here is the chemical formula. What if we have an ionic compound consisting of a transition metal and a polyatomic ion? The name of the transition metal is listed first, followed by its charge enclosed in a parenthesis, then the name of the polyatomic ion. Let us take a look at copper 2 sulfate. Copper is a transition metal with a positive 2 charge, and sulfate has a predetermined charge of negative 2. So we write Cu2 plus and SO4 2 minus. Now, looking at the charges, positive 2 and negative 2 are already balanced, so we could just write CuSO4. Let us now proceed to another type of compound, which is the covalent compound. For naming, we just have to write the prefix plus the name of the first nonmetal, followed by the prefix and the name of the second nonmetal ending in IDE. Here are the prefixes that will represent the number of atoms present for a certain element. Now, let us take a look at diphosphorus pentoxide as an example. Di means 2 and penta means 5. Remember that for covalent compounds, there is no need to balance the charges. So we could just write P2O5. Now let us take a look at dinitrogen trioxide as an example. Di means 2 and tri means 3. So we could just directly write N2O3. For carbon monoxide, if there is no prefix before the name of the nonmetal, it is understood to be 1. However, for the second nonmetal, it should always be indicated. So mono means 1, which gives us CO. Now let us move on to binary acids. These are acids that contain hydrogen and a nonmetal. A binary acid's name always starts with hydro, which tells us that no oxygen is involved, followed by the root word of the nonmetal ending in IC plus the word acid. Now, let us take a look at hydroiodic acid as an example. The word hydro tells us that it's an acid but there's no oxygen involved. So, it's just iodine and hydrogen. The charges are already balanced, so the chemical formula is HI. Next, we look at the chemical formula HF. Note that the oxygen is not present in a binary acid, so the chemical name should start with hydro, so we name it as hydrofluoric acid. Let us proceed to this other type of acid called oxyacid. It is composed of hydrogen and a polyatomic ion. A polyatomic ion that contains oxygen is also known as an oxyanion. For example, nitrous acid. The suffix OUS comes from the oxyanion ending in ITE, nitrite for this example. So NO2- and H+ are balanced, so we have this chemical formula. We also have nitric acid. The suffix IC comes from the oxyanion ending in ATE or nitrate. Both of these ions, as you see, are also balanced, so we have this chemical formula. In this chemical formula, the presence of hydrogen tells us that it's an acid, and the name of the oxyanion is phosphite. The suffix ITE gives an OUS name to the acid, and so from phosphite, it becomes phosphorus acid. Similarly, the presence of hydrogen again tells us that it's an acid, and this time the oxyanion is phosphate. The suffix ATE gives an IC name to the acid, so from phosphate, it becomes phosphoric acid. So there you have it, chemical naming and formula writing made easy peasy. Hope to see you in our next chemistry lesson. Bye!